Hey, what's going on, everyone? Good to hear from you guys yesterday about how Digital Learning Day was going. I hope everyone got a chance to catch up on those assignments from last week. Um, he said I posted those videos from the county and talking about statistics, a lot of the stuff you guys have covered. Uh, in elementary school and should be familiar with some of it, but I wanted to go back and almost look like our normal classroom and class period and go through some of these statistics and describing data information that we need. So uh, make sure you give this video a watch. Great thing about videos, like we talk about, you can stop, rewind, record, do what you guys need to do to get the information, pause it. And once again, please reach out, send me any questions that you have. Um, I'm by my computer throughout the day so I can answer them if you do have a question. So um, what I want for you to do today is kind of take your own notes on his own sheet of paper. You can follow me. I'm going to try and make this as short as possible, but some good information here that you guys need. So here we go. Um, yeah, today we're just going to look at data, and that's what statistics is. When I asked that question last week on about statistics, it's just collecting data, looking at it, describing it, and making decisions based off of that data. And so some ways of describing data involve considering the center. And this is what you guys oftentimes look at when you're talking about grades, when you're talking about um, I don't know, batting averages. You have to look at everything. You're trying to find the center. We use three different ways to find the center. Probably the most popular would be the mean. Mean is averaging all the data that's adding them up, dividing by the total number. The median, did have a few questions about the median. Um, the median is the middle, right? I always think about the median being like when you're driving, the middle of a highway, they call the median, right? So it's the same thing, the middle data value. But the biggest part about finding the median right here is making sure you have to put all of your data in numerical order first. The issue that we run into with the median, if there are two middle numbers, we need to find the average of those two to find the median. And the last one, we don't use as much, but not a bad way to describe a set of data is to find the mode. The mode is the one that happens the most often. And so we can have multiple modes if something happens two or three times. Whatever the most is would be the mode. And so those are our three measures of central tendencies. And key word there, if you go back to the top, measure of central tendencies. Central tendency meaning what one number describes that data the best. And so I'm going to run through it because I think a lot of this is review. Um, and just kind of talk about finding those. And so we look back, and like I said, these are some notes that I clipped together. Of course, our resources are a little limited here from home. And so I do have these that I've used in the past, these notes. And in here, see here described in the mean, we have a data set of 3, 4, 4, 5, 6, 8. They are listed in order. So to find the mean, I would add all those pieces of data up to get 30. There are 1, 2, 3, 4, 5, 6 pieces of data divided by 6, so our mean would be 5. Right? When we look at the median with 6 pieces of data, we have two middle terms, 4 and 5, and so the average between 4 and 5 is 4.5, giving us the median. And once again, the mode, right, is the number that happens the most often. And if I look 4 happens twice, and so 4 would be our mode. So once again, when I'm asking for central tendencies, those are the 3 numbers that I am looking for. And to go back and talk about data sets again, one thing that we will be studying more of this week is the spread. There's more than one way to count the spread, but the easiest way to look at the spread is looking at the range, taking the largest piece of data 8, subtracting the lowest piece of data 3, and our range of the data is 5. So just go back to see the definition. Range is the difference between the highest and lowest values in a set. So we will be getting more into this later on. So as we move forward, like I said, I do have my handy dandy little calculator here. I'm going to try and show you guys a few things that you guys can do in the calculator. It can help us out a lot. But just a few questions here. It says find the mean, median, and mode and range of a data set. Obviously finding the mean, taking these 4 numbers, 85 plus 83 plus 85 plus 82, adding them all together and dividing by 4 because there are 4 total terms. 83.75 would be the mean. Now, when we look at finding the median, order matters. We have to list all numbers in order. Since there are 4 terms, we have 2 middle terms. And so the middle of 83 and 85 would be 84. All right, we talk about mode, the number that happens the most often. 85 does happen twice, so that would be our mode. Our range from 82 to 85 would be 3. Just to go back and talk about mode, not every data set has the mode, and once again, we can have more than one. And so, boom, here's what I want. I show you the answers again for question number 2 here. I've already done the work for you. You can check it. I'd like for you guys to do that on your own. But then number 3, take a second and out of those pieces of data on your own piece of paper, find the mean, median, mode, and range. Let me know how that goes. You can pause the video now. All right, so some of you guys have done that, but as we look and keep moving forward, we're going to start talking about more important things and things that can affect those central tendencies and things that can affect our data and make it different. And here's the big part that I want you guys to pay attention to is keyword outliers. Right, a value that's very different from our numbers. You see where most of our data is. We have a line graph here. It's got all of our points of data on it. If we have a data that's really nowhere close, it is going to affect parts of our central tendencies or some of our central tendencies, some more than others. If we see we have most of our data down here on the left end, this one outlier is going to take our center, where we think our center is, and going to move that mean away from the center of our data. That movement is caused by that outlier, that number that isn't close, and it really is going to skew our information. And so sometimes finding the mean of data with an outlier is not a good way to describe the center. Sometimes to use the mean, we're going to take that outlier out. And so most of us do know. Let me go find this next question. Hold on. That when I look, I say identify the outliers. When I look at these data numbers, 10, 96, 12, 17, 15. I have 5 pieces of data. Most of them are fairly close here, right? 10 to 17, right? But this number 96 is way off. That number 96 is going to be considered an outlier. And so it's going to take our mean. Let's draw a number line real quick so you guys can see this. We have 10, 12, 15, 17, and the 96 way over here. When most of our data is condensed to this one area, it will take our mean and move it away from the center. Our mean. Right, so determine how the outlier affects the mean. It will pull it away. It'll pull it to the right. All right, but let's look. If I'm trying to, let's just go ahead and calculate what the mean is. 10 plus 96 plus 12 plus 17 plus 15. 5 pieces of data. We have a mean of 30. All right, does that 30 look like the center? I mean, look where most of our data is, 10, 12, 17, 15. To me, it doesn't represent our data well. All right, but when we look at the median, my numbers in order, 10, 12, 15, 17, 96. Our median, middle number 15, doesn't that do a better job of representing where most of our data is? I think so, all because of that little guy, the outlier. All right, mode, there isn't a mode, so we can't really talk about the mode being affected. But then we look at our range. Of 86, big range. Probably tells us our data is not going to be stable, not going to be that great. So here's what I want you to do. Pause the video. Question 6, question 7 here. All right, going to pause it here. If you would, I want you to submit your answers to 6 and 7 into the Google Classroom. You can type it into a file, a Google sheet, and send me your answers. But please answer A, B, A, B. You can pause these videos to try and talk about means and medians. Cool. Once you do that, I said we're going to go back into making these box plots real quick. Once again, this should be some of the things they were talking about last week in those videos. We're going to explore looking at the spread of data. And talk about the range, highest number, lowest number. That's cool. But one of the best ways to talk about data is to look at the quartiles. Right, we're familiar with the word quarter. It's talking about putting our data into fourths, and it's really what we're going to be trying to do. When we look at a data set, say all of our numbers are inside of this box, whatever numbers we want to make up. When we find the median, that's going to split our data into halves. We have half of our data below, half of our data above. Our quartiles divided into 4 equal parts. And so, boom, we're going to cut that in half at the lower end. We're going to cut that in half at the upper end. And so what that means is our lower quartile, Q1, lower quartile, and our upper quartile are known as Q1 and Q3. If you notice, it splits our data into 1, 2, 3, 4 equal parts. Our Q2 is our median. So Q1 lower quartile, Q2 is our median, Q3 is our upper quartile. All right, we'll use that data to talk about the lower half, the upper half. And really, most importantly, our interquartile range is talking about that most of our data fits within Q1 and Q3. When I say most of our data, 50% of our data is between Q1 and Q3. So let's look at trying to practice that just a little bit here. So if you look at the data set I gave you down here in these notes, we have a set of data ranging from 1 to 9. If I count all these terms up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 different terms, I can cut that data in half with our median. So 50% of our data is this way, 50% of our data is that way. I'm going to find Q1 by finding the median of the lower half, 3, Q1. I'm going to find the median of the upper half, middle term. Our Q3 is 7. And so 50% of our data, boom, is between those two. All right, so it's important to look at that because we have a range of data from 9 all the way to 1, or 1 to 9, so that's a range of 8. But our interquartile range, our range from Q1 to Q3 should be 4. So it tells us 50% of our data is within those 4 numbers. All right, so we use that data to help us make box and whisker plots. Some of you guys were doing that last week in your assignment. And so I'm going to do one box and whisker plot, and we'll leave it there today. So use this data to make a box and whisker plot. What do we need? A couple things, 5 things. First thing, what is the lowest number? Well, if I look at my data, is it in order? No, first place we want to start, put it in order. 21, 24, 26, 26, 28, 31. So we have 1, 2, 4, 5, 6 different terms. 1, 2, 3, 4, 5, 6 different terms. What's our lowest data? 21. All right, we also want to find Q1, our lower quartile, 3, our median, which is Q2, 4, our upper quartile, Q3, and 5, our highest data piece, which is 31. So making a box and whisker plot, going to draw a number line from our lowest 21 to our highest 31. I put points at both. Easiest thing to find first would be cutting my data in half and finding the median. 1, 2, 3, 4, 5, 6 terms. So my median is between those two numbers. They happen to be the same number. So our median is going to be 26. 26 should be right in here. Boom. That is our median. We'll draw a line, draw a dot right there because that's going to be the center of our box in our box and whisker plot. All right, so now since I found our median, next piece is going to be finding, let me go ahead and write that down. Our median is 26. I need to find Q1 and Q3. All right, so finding the lower quartile, Q1, take the bottom 3 numbers. All right, this is the lower half of my data. The middle number is 24. Boom, Q1. This is going to be the edge of my box in my box and whisker plot. All right, Q3, top three numbers, top half of my data. Boom, middle number 28. 28, 24, boom. 28 should be here. Boom. So Q1, Q3 are the edges of my box. In the middle of my box, I have my median, and then I'm going to connect those lowest and highest points, right, to complete our box and whisker plot. So hopefully that helps with making box and whisker plots. Got a set of data here on that same file. You answered those other questions on. If you would, please do the same. All right. Notice a lot of numbers. Make it nice and pretty box and whisker plot. Turn that in. When you go to your Google Classroom, you can see the assignment. All right, in the top right, upload that if it's a picture. If you drew it out, I don't care. I'll work with you guys on all that. But if you will upload it and then press the turn it in button, there is a turn it in button there that I need you guys to click so I can get it. Hopefully that helps. Enjoy your day, get it done, and there'll be more tomorrow. All right, see you guys.